Joining our Coalesce session today. My name is Andrew Tom. I'm a senior data analyst at DBT Labs and also your MC for this session. I'm really excited for this session because if you've worked in data, you know the anxiety-inducing question of how is this field calculated and what fields did you pull from? And so it's times like that when I wish that I had seen a talk like this. The title of this talk is Field Level Lineage with DBT, ANTLR, and Snowflake. And I have the pleasure of introducing our three speakers. So our first is Mei Tao, and she is an investor turned PM. And previously she worked in product management roles at a logistics tech startup. Her fun fact is that she loves spicy food and once ate a bottle of hot sauce in under an hour. Wild. Also joined is Xuanzi Han, who's a senior backend engineer at Monte Carlo. And her fun fact is she has a dog named Data. Last but not least, we have Helena Munoz, who's a senior front-end engineer at Monte Carlo. And her fun fact is her children painted the entire house. Is that right? Wow. Cool. Quick housekeeping. So all chat conversation and Q&A will take place on the Coalesce Field Level Lineage channel. So if you haven't already joined, now's your chance. And for those tuning in, if this is your first session, please join our community Slack at community.getdbt.com. Last but not least, after the talk, our speakers will hang around in chat for a little bit to answer all your questions. So feel free to drop questions in the chat as they come up, and our Slack monitors will help keep track of all the questions being asked. And without any more to say, I'd like to turn it over to Mei. Thank you so much.
Right. Thank you so much, Andrew. We actually will do a pop quiz later based on Xuanzi's fun fact. The quiz is, what is it called when Xuanzi's dog takes a nap? And we'll see if anyone can come up with something at the end of the presentation. And there will be a gift if anyone has a good answer. Yeah, actually, before we dive in, I'd love to do a little bit of survey. Curious if you can, by show of hands, has anyone built a field lineage or attempted to build a field lineage? Can you raise your hand if you have? Okay, like less than 10 I'm seeing. And has anyone used a field lineage, whether it's from a vendor or from something in-house? All right, okay, so still a small percentage. All right, let's get started. So Andrew already did our intro. That's us, an all-women team from Monte Carlo. Pretty hard to come by these days. A quick background on Monte Carlo. We're the creator of the data observability category. The category is about 3.5 years old, and we are about 3.5 years old. In a short amount of time, we were very fortunate to be able to raise $200 million fundings in venture capital from some of the top investors, including Excel, GGV, Redpoint. We're also very excited to be working with a long and growing list of customers, including Fox, Pepsi, CNN, JetBlue, and a lot of these customers are also passionate users of DBT and customers of DBT Cloud as well. The problem that we're trying to solve is data downtime. What is data downtime? Could be a table that is missing an update or a broken BI report that gets sent to your CEO. Any period of time where your data in your data infrastructure that is missing or incomplete or inaccurate, these are all what we call data downtime. And there's some serious impact from data downtime. What we're seeing is that for data engineering teams, they're spending up to 50% of their time fighting fires. That is time that they could have allocated to more productive and creative work that's lost from data downtime. We're also seeing companies having 20% of their revenues on average being impacted by poor data quality. And the approach that we're taking to solve this issue is data observability. And we take an approach to automate the entire incident management workflow from a 3-step process. First, we aim to detect when there's a data issue as soon as it happens. And once we detect the data issue, we want to provide you with the tools to find the root cause for it, to run root cause analysis. And finally, we want to be able to prevent data incidents from happening from the first place. And the field lineage product that we will deep dive into today will serve a core component as both the resolution and the prevention workflow. So let's go into it. Why did we build field lineage? When a lot of our customers are asking for field lineage from us, there are two buckets of questions that they're asking. One is around impact assessment. For a field broken upstream, what is the downstream impact? For data analysts, maybe you want to deprecate a column upstream, and you want to be able to assess what are the exact fields downstream that will be impacted. So once you do that accurate assessment, you can safely and confidently deprecate the column without worries. Second bucket of question that we hear is around root cause analyses. For error upstream, what is the downstream, what is the upstream cause from it? So if there's a high null percentage for a field downstream, what are the upstream DBT models that might have the fields that also have the high null percentage? Next slide. Once we have built a foundation for field lineage, we will be able to create critical features on top of it. One example is we can calculate importance scores for fields. For a list of fields that an analyst is using, we can calculate field importance score based on the upstream and downstream field level dependencies on those fields. And the data analyst will be able to quickly spot what are the most important fields from a table, so they can leverage those fields to build DBT models or create monitors on top of it. Another example is assessing impacted reports on your BI layer. If you have a field that has issue upstream with a table lineage, you will be able to narrow down to potentially a list of 50 reports that are impacted by potentially different fields on the upstream table. But with field lineage, you'll be able to narrow down to a much shorter list, maybe 5 reports that are exactly impacted by that one field upstream. So instead of pinging the owners of 50 different reports, you only need to ping the owners of 5 different reports. Quickly help you narrow down the impact treatment. Next slide. With that said, there's a lot of complexity with building field lineage. On the front end, there's this complex web of relationships that we need to be able to present in a clean and efficient manner. On the back end, there are hundreds of SQL operators and combinations of SQL operators that we need to be able to parse. And on top of that, there are different types of dependencies or impact from the different types of field level relationships. So for a select SQL clause, it creates a more direct relationship between the source table and the downstream table. But for a where clause, it's oftentimes used to filter the source tables to result in a list of rows in the destination table. So that's another layer of complexity that we will need to be able to reflect. So what we did is we took it to our customers. In addition to the use cases that we've heard from customers, we came away with a few key lessons. One is people want automation. The existing solutions that our customers potentially have access to require them to define this upstream table 1 field A is impacting downstream table 2 field B. You have to manually define them one by one, and with hundreds of columns and thousands of tables, it will take forever to define your field lineage. So being able to surface that in an automated fashion is something that will be critical for our customers. And secondly, we realize there's no existing tools. What our users are doing are completely manual. They're looking up their SQL query log and manually parsing through 50 lines of code and manually listing out the fields that are referenced in those code. And what they're saying to us is like, this is taking too long. If you can give me anything, it's better than nothing. And additionally, we narrowed down to a list of the most popular integrations that will be critical to our users. That includes DBT, Snowflake, BigQuery, and a few others. And finally, we also realized there's very little awareness in terms of the understanding of the complexity of building field lineage. and what the different types of clauses that are involved. There's very mixed needs based on different customers' requests. But what we have learned is that select path is seen as either more important or as important as all the other SQL clauses out there. So with that, we were able to scope an MVP that we were able to ship in a mere 2 months. And those are based on a few critical requirements. One is we're going to automatically parse query logs, so it brings fast time to value. 2, we are only going to show in UI 1 layer of upstream dependency and 1 layer down. And in order to traverse further up or further down, users can click on each of the fields to travel up and down. And for the hundreds of SQL operators out there, we decided to apply the 80-20 rules. So spend 20% of the time and achieve 80% of the coverage. However, over time, we were able to add coverage for different clauses 1 by 1, and we were able to achieve closer to 100% coverage after. And finally, we decided to distinguish select clauses from the other SQL clauses out there. And with that, I will hand it to Xuanzi to show you how we actually built it.
Thank you. This is Xuanzi. I'm so happy to be here to share how we built field-level lineage at Monte Carlo. Probably as everyone here already know that whatever happens in a database, no matter it's like you're creating a table, deleting a table, modifying a table, inserting data into a table, it all has to go through some kind of queries. So we decided to build most of our field-level lineage based on queries that happen at our client's data warehouses. Yeah, first I'd like to show a general architecture of our lineage pipeline. As you can see on the most left side, we have a data collector sitting on our client side. So periodically, this data collector will collect all the query logs and then send it to some Kinesis stream. This Kinesis stream is consumed by a Lambda function within Monte Carlo. And so whenever this Lambda function, the query log one, gets a query log, it will send the query to the query parser. It's like a string into the query parser, then the query parser will return a structured lineage data back. And once this Lambda function gets a raw lineage, it pulls metadata from our database to resolve the columns and tables using the lineage, and then send the resolved data to another Kinesis stream. And after some further processing, the data is eventually indexed into Elasticsearch so that our service can query the data in a flexible way and serve the data through our GraphQL API to our clients directly or through our UI. So the most challenging part of building this whole thing is the query parser part. So how does our query parser work? It takes a string of a query as input and generates a structured lineage data. As we show here, if you see on the upper top, it's actually a very simple query. We are selecting 2 columns from a table named table, and we are using a column in the where condition. So on the bottom is like the lineage generated from that. We have the sources column, which contains all the source tables used in the query, and also we have the columns lineage. There contains all the columns defined in the select clause. The selected column means like the name of the column used in the result of the query, and the source column and tables indicates what are the columns from which tables are contributing value to this column directly. And also we have the non-selected columns. There, all the fields that are used in a where condition goes to that part, so that we know what are the fields that influence the data eventually gets into the result of this query. So we use ANTLR to build our query parser. ANTLR is like a very powerful parser generator. It allows you to define grammars, and based on the grammars you define, it creates a parser. So it takes the input as take a string input and then generates a tree structure. And it also provides you a walker to allow you walk through the tree structure to extract useful information you need. Our parser is actually built on top of an open source grammar that was provided for Presto. Based on that, we built support for most grammars in Snowflake, BigQuery, Redshift, and a bunch of other query engines. So if you're using DBT like on top of any of these query engines, Monte Carlo will be able to like automatically generate the table and field level lineage for you. For the tables that you defined in your DBT models. Yeah. And now I want to go a little bit deeper into the query parser. So ANTLR provides two ways for traversing through the tree structure. The first pattern is the visitor pattern. The second is the listener pattern. Both of them actually do DFS, but the difference is that the listener pattern kind of access the nodes in a more flat way. So it calls the user-defined function on specific types of nodes when it visits the node. But it's really hard to carry any states or contexts to that node. We actually had our first parser based on the listener pattern. It was working for 80% of the queries. But for some queries that has lots of like common table expressions or like lots of nested subqueries, it was just not working very well. So we switched to the visitors pattern. With visitors pattern, it gives you the flexibility to choose, at a node point, do you want to go to the children nodes or stop somewhere? And also it's much easier to carry like the states. In our case, the states are like resolved lineage, to use resolved lineage to resolve some other queries. For example, here's a query on the right side. It's actually a not very complex query. Under the with clause, there are like non-common table expressions. And some of them are using the common table expressions defined before them. So we need to use the resolved lineage above them to resolve the later defined queries. And also in the main queries, you can see we are joining a CTE with like a real table. Actually, in reality, there are lots of like more complex cases, like they can join between real table, CTE, and subqueries. And each of these sessions, they can have like functions, expressions, and also subqueries, and combination of those. So it's really complex. With the visitor pattern, our parser now is able to parse some really complex queries, like recursively go deep to resolve subqueries and then use the results to resolve some outer queries or like vice versa, like that. Of course, it is actually not perfect yet, but we are just keeping improving our query parser along the way while we see like more queries from our client side. And it's not just us, like thanks to our amazing engineering team, build a strong foundation infrastructure so that we can get this done in 2 months. Now I'm gonna hand this to Helena. She's gonna give us a demo.
Thank you, Xuanzi, and thank you, Andrew, for the great introduction. My name is Helena. I'm part of the engineering team at Monte Carlo. And I'm going to show you now how field lineage actually looks in Monte Carlo UI and show you a different use cases scenarios on how you can actually harness this feature. So I'm going to start in the catalog page of Monte Carlo. So the catalog page in Monte Carlo shows everything related to the table. And for the example I'm going to demo, I'm going to show the client hub table. That is a table we use internally in our own dog fooding account for storing customer information. So I'm going to open this table in the catalog view. Great. And here I can see a bunch of things around the table. First of all, as you can see here, I can see the freshness of how often this table was updated. I can see the volume, so how many rows this table has been getting per day. If I had the DBT integration connected to Monte Carlo, I can come here and see the models used for generating this table in DBT, and if there was any error when running the models, I'll get here and be able to see the logs. And then on top of all that and other features, we also expose here the field lineage feature. So This particular table has 4 different fields. So it has the created on, account ID, client, and number of users. So the idea is that here we're storing per customer how many users we have in Monte Carlo. So I'm going to select one of the fields so that we see the field lineage for that particular field. So I selected the created on. And here I get a graph with 3 different nodes that shows the lineage. So the node in the middle has the selection. So it has the table, the client hub table, and the created on. That's the field that I selected that I want to analyze. And then on the left-hand side, I have the list of upstream dependencies for that particular field. And on the right-hand side, I have the list of downstream dependencies for the field. So the dependencies are grouped by table. So in this case, the created on field depends on the prod stage accounts table. And if I expand this table, I'll get a list of all the fields that are used for populating the created on field. So in this example, as you can see, the fields are grouped in 2 different categories, the select clause lineage fields and the non-select lineage fields, which as Xuanzi and Mei mentioned before, we are categorizing depending on how these other fields are used and if it's if it's used in the select clause or if they are used in other classes, for instance, in the where, in the join, or so let's say that I want to get more information. I want to actually see these fields in context, and I want to know exactly how it is that they are getting used. So I can come here and select the SQL query button, and I will actually see the SQL query that was used for generating the client hub table, and I will get all the information of all the fields used in context. So for instance, in this case, we have here a table alias that's called accounts. That's the prod stage accounts table that we have over here. And here in the select we're using for creating the table, we are selecting the accounts created on field. So that's why we are displaying the field in the select clause lineage list. And then, as you can see, we're doing a where and group by clauses here that are also very relevant in this case, because if, for instance, the where clause changes, then the content on the created on field is also going to be affected. So that's why it's also very, very important to consider the where and group by clauses. So in this case, we are grouping by these 3 fields, created on, account ID, and name, and where clause with account and name. So that's why here we see these 3 fields because the account name is actually used twice. This particular information is very, very useful if I want to know if the information on the created on is accurate or not, and I want to understand where it comes from. So that's why the upstream dependencies here are very important. Let's say that now I want to analyze the downstream dependencies for the field. So now I'm going to select a different field. Let's, for instance, select the client field. And as you can see, the UI updates to reflect that. So in this case, the field lineage for client is very different to how it was for the created on field. And for instance, for populating client field, we use account name in this case for the same table. And then on the downstream dependencies, we'll get all the places in my data pipeline that the client field is being used. Okay, so as you can see here, there are a bunch of tables. There are also local reports, and again, they are grouped by table or by report. And I can further extend that and get the exact detail on all the fields that use this other field. This is particularly helpful, for instance, if I want to deprecate the client field and I want to know all the places that would be affected, or I want to double check, like I want to deprecate this field, I want to double check that it's really not used in any part of my stack, so that I can come here, select the field, and I can see exactly where I have to modify and what I would have to refactor when I deprecate this field. The other use case scenario for this could be if I have, for instance, sensitive customer information in the field, and I want to know how that customer information is propagated across my data pipeline. So then I would have a very detailed report of all those places. So now let's think of a different scenario, and let's say that I have a DBT metric defined over this model. So I want to generate a metric that gives me the total amount of users of my application, okay? as I mentioned before, in the Client Hub, we actually have the number of users per customer. So in order to calculate this metric, I have to aggregate all the information in the table and then sum the number of users. So now with dbt, we can do that and define a metric. And the great advantage of doing that is I can actually share with all my stakeholders how it is exactly that this metric is calculated, which is great. But what dbt doesn't help me with is saying, okay, what is the quality of the data? So I can tell everyone, okay, this is how it's calculated, but the final number would also depend on the quality of the data that it's used to calculate the metric. So that's when Monte Carlo, and in particular field-level lineage feature, come in very handy, because now what I can do is to check, okay, what are the fields that are being used to generate this metric. In this particular case, I can see the number of users field is used. So I can come here and select number of users, and I'll get all the fields and all the tables that are used for populating that particular field. And then in turn, I can actually also navigate into our table lineage feature and see whether in my data pipeline there's any incident that's affecting the upstream dependencies for those particular tables. And that would give me confidence in saying to everyone, hey, you know what, yes, you can definitely rely on this metric, it's right, because there are no incidents. I'm very confident about this working. On top of that, we also have a dbt section where you can actually check if your model and tests had run correctly. So in this case, actually, some of them have failed, and then you can check the logs inside Monte Carlo and see, okay, well, actually this failed, but maybe it's not related, so it won't affect my metrics, so I'm good to go, and things are still okay. Yeah, okay, so that's it for us for now. So I want to wrap up by saying thank you all. It was a pleasure. I want to actually do a couple of invitations. But first, maybe we can actually do the quiz.
Anyone come up with an answer?
All right.
I'll hand over a gift.
Yay. Well, as Andrew mentioned, we'll be around for questions later on, but I also wanted to invite you to next week Impact Summit. That is the second summit that we're organizing in Monte Carlo of data observability. Tristan Handy, the dbt Labs CEO, will be there giving a keynote, and also Daniel Kahneman, author of Thinking Fast and Slow, and Nobel Prize-winning author. So it's, it would be an amazing event, so you're all invited to participate. It will be next week, the 25th and 26th of October. So it was a pleasure having you all here today. Thank you.
Thank you to our speakers for a great presentation, and thank you all for joining us. Just a reminder to drop your questions and comments in the Coalesce Field Level Lineage Slack channel, giving the speakers some time to settle in before they respond to questions, so don't be alarmed if they don't answer your questions right away. The next talk in this room will be Snowflake Yourself, using dbt for Snowflake Access Control Management, and that'll start at 4:45 Central Time. See you then.